Morning. Hello, good morning. Is it audible? Good morning.
Good morning, sir.
Yes, yeah, okay, thank you. So last class we have seen about finding shortest path using distance vector protocol, routing protocol using Dijkstra algorithm. We have started from destination node. Then we have found that the shortest path with respect to destination nodes for each node. So next is Dijkstra algorithm, that is a link state protocol algorithm. Here we are going to start from source. We are going to float that entire link state informations to the neighborhood node. From that, we are going to find the shortest path to the remaining node with respect to the source node. So for that fact, you may expect either problem from Dijkstra or from that Bellman for algorithms. That is either you can expect problem from distance vector routing protocol or link state protocols. It is also very simple problem. So today we will see one problem, then we will move to the next module. So link state algorithm name itself, it implies that it will share the respective details of the link to the remaining nodes. It floats the link informations to the remaining nodes. So basic idea, it is a two-step procedure. The first one, each source node gets map of all nodes. Each of the source node will get a map of all the neighbor nodes, that is nearby nodes. Then link matrices of the entire network. So find the shortest path on the map from source to destination. So for example, finding the shortest path in the order. So the first order, the closest the node to S, that is, it is one hop away. It is either it is a W dash, W or W double dash. So let us consider we are selecting W dash as well as W. Then we are going to select W double dash. The second closest node to the S, here there is no nothing, there is no node is there. So the second closest node, it is only belonging, it is it is very closest to W double dash, because it spread all the informations to the neighborhood node. So all these are with the same distance. So W dash, W double dash. So it is added in the respective list. Then if you see here, then if all these things flow the informations, here there is no neighborhood node, only it is having neighborhood nodes, it spread the informations to here or here. Either it will go to here or it will go to here. You see here, comparing to the distance, this is high, the distance is high. So it is including this into the respective things. The third one, so it will spread the informations or links information here to either this or this. So next, this is the closest node. So this way it find the respective that the shortest path with respect to source node with the remaining node. It load all that links and informations, then it find which one is shortest, then it is select that into the respective group. So the algorithm, uh, first step, n, it is nothing but the set of node for which already the shortest path has been found. During initial stage, n will contain only the source node, because we are not find any shortest path node in the starting stage. So during initialization, n contains only s, that is the source node. N is a set of all the nodes. During a sorting stage, initialization, n contains only the source node, because we are going to start from source, then we are going to find the respective shortest path, the remaining nodes. So starting stage only s will be at the set of node. So ds equal to 0. The even last class also we have seen that distance between node to the node itself, it is 0, because the distance between node, the distance between s to s itself, it is 0. So ds equal to 0 at the starting stage. Now The dj, it is nothing but C as Fsj for all nodes. Suppose let us consider this is node j. What is dj? Dj, it is nothing but Csj. The distance between these two, this plus the respective ds. Here ds is 0. So dj is equal to Csj. If j it is not equal to s. If it is j is equal to s, then that is nothing but the source node. So we are going to find dj is equal to Csj. We are going to assume that. The first step, so find the next closest node to I. Let us consider we are starting here. This is I. So find I, it is not equal to n. Suppose if I it is there in the n, no need for going to further. So find I, it is not belonging to n such that di is equal to minimum of dj. That is the distance between these two neighborhood nodes. Suppose for example, it is containing 3 to 4. So di is equal to minimum of the dj. So first, we are going to include the minimum distance node into the n. That means add now I to the n into the n. So n contains all the nodes. If n contains all the nodes, for example, in the respect network, if it is 6 nodes, if n contain all the nodes, you can stop. Otherwise, you can go to next one, update the cost. For each node j, if it is not belonging to n, suppose if it is not in the set of n, then we are going to find dj is equal to minimum of dj comma di plus j. Then we are going to find the distance. Here it is equal to the minimum of dj. Then it is a di plus the previous stage. Di plus this is dij plus di. So dij plus di. So we are going to find the minimum. Then we are going to replace that with the dj. Then again go to the step. Again repeat. You see the problem. So the same problem, what we have seen for distance vector routing protocol, the same problem that we have found the shortest path from the that is destination node 6. Here we are going to find the shortest path from the source node 1. We are going to find the shortest path with respect to 1 to the remaining nodes. So it is very simple, very simple. During the initial stage, because we are going to start from 1. So only one will be in the set n, because we have seen that n is yes. During initialization, n is equal to yes. Only that the source node will be in the set. Only n is equal to n. So next we are going to float all the informations. Then we are going to find which one is the shortest node. So we are going to float the links information to all the node from here to here, because starting d1 is equal to 0. That means ds is equal to 0 initialization, because the distance between node to the source node to the node itself, it is 0. So d1 it is equal to 0. Now we are going to float this link state to the neighbor node. Here the neighbor node 3 5, that is 3 4 2. This is neighbor node. So we are going to float this. So how will you update this? So d3 equal to d1 plus distance between the 1 3. So d1 is 0, this is 2, this is 2. So d3 it is 2. Similarly, d2 it is nothing but what is d2? So d2 it is equal to d1 plus c1 2. So 0 plus 3. So d2 is 3. Similarly, d4 is 5. d5, d6, it does not contain the connections directly to that. So we cannot able to float the link state to all the neighborhood nodes. So this is infinite. There is unknown state. Now if we check here, d2 is 3, d3 is 2, d4 is 5. We are going to include the minimum. Yeah, if it is which one is contains minimum, that will be added into the n. You see here, this is the minimum. So the node 3 will be added into the set during the second stage. Now the d3 will be added into the set. Now d3 will be added. It is bringing to here. Now so 1 as well as 3. So next step, again we are going to float the link state from 1 to neighbor node, 3 to neighbor nodes. because now in the set 1 and 3 is there. We are going to float all that link state to the neighbor node with respect to set of n. So 1 to all the neighbor node, 3 to all the neighbor node. Again, we are updating same thing. Now, what again D2. So D2 is equal to neighbor node, it is 1 only. So the same procedure, D2 is equal to D1 plus C12. So here it is 3. I am updating, here it is 3. So in the D3, since it has been included in the set, there is no change. That is reasons color has been changed here. It is already, it is included in the shortest path sets. Now D4, we see here, so the floating informations will be flowed from node 1 as well as from node 3. So D3 now it is 2. Now the 4 will receive the floating link state from 1 as well as 3. So through 3 at D4, what is the value? At D4, if I'm coming through 3, D3 plus C34. So D3 it is 2, 3, 4 it is 2. If it is coming through this, it is 4. It is coming through this, it is 5. So I'm going to take it minimum. So now D4, if it is 4. D4 it is 4. D5 it is not connected, so it is infinite. Now D6. So D3 will float the link state to D4 as well as D6. So D6 is equal to D3 plus C36. So 2 plus 1, 3. So it is 3. Now if we see here in the second state, D2 it is also 3. D6 it is also 3. So we are going to select D2, that is having the lowest node. Now D2 node, now node 2, now it is included in the respective the set of n. So now 2 is included here. So 1, 2, 3. So 1, 2, 3. Now it is in the set of the shortest path. Shortest path. Now, so 1, 2, 3. So all the 3 has been included. You see here now, all the 3 has been included. 1, 2, 3. So all these things now it has been included here. Now if you see here, so this is also included. This is also included. This is also included. Okay. So the next step. So now this 1, 3, 2 will float the link state to neighbor node. 3 will float to 6 and 4. 1 will float to 4. 2 will float to 4 and 5. So now we are not worrying about D2, D3. So D4. What is D4? So D4 will receive information from D2 as well as D1 as well as 3. So now we are going to select minimum. If it is floating through D3, it is nothing but already it is 2 here, it is 3 here, it is 0 here. So 2 plus 2, 4. In this directions, it is 4. From here to here, it is 5. From here to here, it is 4. So it discard these things. Either it will select these directions or it will select these directions. It is going to include only the 4 as the distance. Now 4 as the minimum distance. So next. So they know that node 2 will float to 4 as well as 5. Previously 5 is infinite. Now you know that node 2 will float the link state to 4 as well as 5. So D5, if you see here, so D5 equal to D2 plus C35. So 3 plus 4, it is 7. So now it is 7. D6 only flowed from 3. So 2 plus 1, 3. Now if we check here, already 2 and 3 has been included in the data set, in the node set. From 4, 5, 6, you should include with the minimum. Now this is the minimum. So now 6 has been included in the shortest path set. So 1, 2, 3, 6. Now 6 is included. 1, 2, 3, 6. So now 6 is also included. So 2 is also included, 3 is also included, 6 is also included. Now except 5, all that is except the 4 and the 5, so remaining has been included. Now the same thing, because during each and every stage only we should include only one the node into the set, only one node into the set during each and every stage. Again the next step, next step, so all the information again will be flooded. Now, so
Hello.
yes.
So, can you explain D4 in the second iteration? Like,
Here,
yes,
second
sir.
iteration.
Yes, sir.
Okay.
Yes, sir.
Yeah. Okay. Now during that second iterations. So previously, that 1, 2, 3 are in the set of shortest path. So 1, 2, and 3. So D1 it is 0, D2 it is 2, sorry, D3 it is 2, D2 it is 3. So if you see here, D2 it is 3, D3 it is 2. Now during this stage, the node 1, 2, 3 will float the link state to the neighbor node. So 1 will float to 4, 2 will float to 4 as well as 5, 3 will float to 4 as well as the 6. Now, so we are not bothering about D2, D3 with respect to 4. Now 4 will receive the link state floating from node 1, from node 2, from node 3. So here we are going to calculate D4, then we are going to select the minimum values. So now here D4, it is equal to, let us assume it is floating from 0, that is 1. So D1 plus C14, this is 1. Remaining, so let us assume it is floating from node 3. So D3 plus C34. Let us assume it is floating from 2. So D2 plus C24. First one, D1 plus C14. D1 is 0, C14 is 5. So it is 5. So in these directions, if it is floating, it is 5. So next, from 3 to 4, D3 plus C34, D3 is 2, 2 plus 2, 4. If it is floating these directions, it is 4. Similarly, if it is floating from node 2 to 4, again D2 plus C24, so 3 plus 1, 4. So from 1 to 4, it is 5, 3 to 4, it is 2, 2 to 4, it is 4. So all these except this, here it is 4, it is 4. So it will select minimum. It won't select this cost. It will select 4 as the minimum cost. So 4 as the minimum cost. Either it may be from 2 to 4 or it may be from 3 to 4. But here we are going to only update the respective cost. Now D4, it is 4. It may be from 2 to 4 or it may be from 3 to 4. Now once we are finalizing minimum cost, then we will finalize node from which node it is coming. Here both the directions it is same. So we are taking only the 4 as the minimum cost. Now it is 4, it is 7, it is 3. So in this stage, already these two are included. This is 4 and 7 and 3. Among these, which one is minimum? D6, it is the minimum 3. So now node 6 is included into the set of the shortest path node. Now 3, 2, 6 are included. So during the third iteration, during the third iteration. Now, if we see here, D2, it is 3, it is 2, D6, it is 3. Okay. Now, during the next iterations, so all the information will flow from 1 as well as 2, as well as 3, as well as 6 to the neighbor node. We see here, from Z, that is 1, it flowed to 4, 2 will float to 4, sorry, 3 will float to 4, 2 will float to 4 as well as 5, 6 will float to 5, 6 will float to 5. So we have to find only D4, D5. Now with the same procedure for the D4, it received the linking state from D1, D2, D3. The same procedure what we have seen in the previous the iterations 2. We are going to repeat the same thing. With respect to 1, it is 5. With respect to 3, it is 4. With respect to 2, it is 4. So minimum it is 4. So minimum it is 4. Minimum it is 4. Minimum, if you see here, it is 4. Now, similarly, so for the 5, it will receive the floating from either 2 or either 6. If it is through 6, so D5, it is equal to D6 plus C65, 3 plus 2, it is 5. Similarly, suppose if it is receiving through D2, so D2 plus C25, so 3 plus 4, 7. In this direction 7, in this direction 5. So minimum is 5. It is selecting as 5. It is selecting as 5. Now already 2, 3, 6 has been included. If we check D4, D5, D4 it is the lowest. So we are including D4 into the shortest path. So 4. So next iterations 1, 2, 3, 4, 6. So 2, 3, 4, 6. Now it is included into the respective iterations. Now only remaining it is the D5. So same way we are calculating D5. We are calculating D5. So it is 5. It is 5. So next stage we are going to include D5 also here. So 1, 2, 3, 4, 5, 6. All it is there in the node. Again we are repeating the same procedure. Now there is no further new node after this stage. Already all those node has been included in the shortest path. So there is no further the node to include. Now we are going to stop it here. So now this is the set of shortest paths. We are going to draw the tree diagram based on this. Based on this 1, 1, 3, 1, 2, 3, 1, 2, 3, 6, 1, 2, 3, 4, 6, 1, 2, 3, 4, 5, 6. We are going to draw the tree diagram based on the set of node. Starting stage 1. Next stage 1, 3. That is from 1, 2, 3. So this red line indicates the respective the tree diagram. So during the second iterations, 3 has been included. That is 1, 3. Next stage 1, 2, 3. So 1, 2, 3. Next stage 1, 2, 3. So next stage 1, 2, 3, 6. So 1, 2, 3, 6, 6. Then the next stage 1, 2, 3, 4, 6. You see here 1, 2, 3, 4, 6. So the next stage again it includes the 5. You see here. So this is the shortest path diagram. You see here. This is the shortest path a table, a tree from node 1 to the remaining nodes. Node 1 to the remaining nodes. So this is using the link state protocols. So we are going to find the shortest path tree from source node to remaining node. So kindly go through this the problem. So this is the sample problems. So you can cross check with the answer. So you can solve the few problems using distance vector routing protocol or using that link state protocol. Then practice more number of problems to find the shortest path. So this will support for your that future research paper also. Suppose if you are working on D2D or we are working on any that wireless communications, always you have to find the optimal path, shortest path. There you can use either Dijkstra algorithm or you can use Bellman-Ford algorithm to find the shortest path between that use requirements to the neighbor D2D node or neighbor. Maybe if you are working on FOC mode, you can be able to find minimum distance between that your user requirements to the FOC node, FOC server. So this algorithm will helpful for your the future research also in the communication networks, wireless communication specifically. So the next module, it deals about local area networks, that is Ethernet, token busting, FTTA. So now we will see about the introduction about that module. Then next class, I think we will see a few problems in the module 4. I think this is full and full theory. You heard about a LAN. So it is nothing but connecting more number of node using a server in a single network. So the local area means it is need to share the resources, because if server is there, we can be able to share all the informations through server to the rest of the world. Either you can create private things, or you can create the public LAN also. In the LAN, the distance should be very, very high. I think we studied about LAN, MAN, WAN. LAN, it should be around 500 meters, maybe within the single block or within the lab. So here, the machines are always, it is constantly moving to all that, all the node. Maybe you can share that broadcast to all the message or whatever thing. Only thing, so the LAN requires, it needs the MAC protocol. So this is nothing but network interface card. I think this you have seen in your computer or in the laptop. So this is the network interfacing card. So this network interface card which will support to connect LAN to your other systems, So any typical LAN, it include transmission medium, that is the cable, or it include network interface card. Then it include that the physical address. So the physical address which is used to identify the respective the systems which is connected in a particular network, because the MAC address, physical address, it is constant, it won't vary. That physical address, MAC address, it is nothing but address of the network interface card. It is address of the network interface card. It is an inbuilt card in any laptop. So NIC, it contains the physical address. So using NIC card, using physical address, you can be able to identify the respective physical address the systems. Then that NIC card, that is network interface card, which is used to connect your systems with the LAN cable. So normally, data link layer, you can divide that into two as per IEEE standard. So you can divide that into two, because if you see here, physical layer, it is the lower layer, then data link layer, then network layer. Now this data link layer will support both to the physical layer, then network layer. So you can divide the data link layer into two layers. So the lower layer will support to the physical layer, upper layer will support the network layer. So this lower layer, it is called as the MAC. Upper layer, it is called as the LLC, that is a logic link control. So this lower layer, the MAC sub layer, will coordinate access to the medium through physical layer. It is a connectionless frame transfer service. It identifies using that MAC and physical address. It broadcasts frames with the MAC address. MAC address. So broadcasting frames will be mostly based on the MAC address. So this upper layer will create interface between a network layer to the respective data link layer using IP address. So here at the upper part it is IP address, lower part it is a MAC address. So you can divide data link into two. So the lower part it is used to identify the MAC address which will connect physical medium. Upper part it is an LLC. It will uses IP address to connect through network to the rest of the world. To the rest of the world. So if you see here, you can divide a data link layer into two. I told you know MAC and LLC. So this uses IP address to connect to rest of the world. So this uses physical address. So various MAC are token ring, CSMA CD, wireless LAN, as well as token bus. Many is there. We will see about the one by one. So normally that you know, if the MAC, if it is the single one, it cannot provide the reliable connections because always you know that data link layer will support will connect both physical as well as network layer. So physical layer it deals with MAC address, network layer deals with IP address. So if you know that both it supports, suppose you know data link layer it supports with the both, automatically you can be able to transmit reliably information. Suppose if LLC it is not exist, then it is very tough to the connect your the respective MAC address or system with the rest of the world with the frame service with the frame service. So LLC that is you know logic link control layer also plays a vital role to transmit information reliably from your node to rest of the world. Rest of the world. So here IEEE Ethernet IEEE 802 it uses HDLC service. I think this we have seen in the previous things HDLC service. So there I think we have seen about that is you know asynchronous balanced mode, normal response mode. Then we have seen about unacknowledged frames. Then we have seen about S frame. Then you know I frame all these things. So similarly type one it is nothing but it deals with the respective U frame, uh, this I frame, this S frame. This is acknowledgement. This unencoded frame, it is nothing but U frame to establish the connections. Then here the transmission is taking care, it is I frame. Type 1 it is U frame, type 2 it is I frame, type 3 it is S frame. S frame. So even using HDLC, you can be able to provide service to the MAC layer. MAC layer. So this you can refer theory. So the Ethernet it works on the MAC address. It is there in the MAC. It is there in the MAC. So it supports for CSMA CD. I think CSMA CD you studied about digital communications and digital communications. So carrier sense multiple access techniques with the collider reductions. That is here. So it is a multiple access techniques. It is mostly it is used in the physical media, physical layer. So that IEEE 802.3 it supports for the CSMA and the C. So that actual IEEE 802.3 the parameters. It is transmit rate, it is fixed in IEEE 802.10 Mbps. So minimum frame it is 64 bytes in IEEE 802. That is in if it is 512 bytes 64 into 8. So the slot time required to transmit it is nothing but the frame size divided by transmit rate it is 51.2 microseconds. So similarly, this Ethernet will support with the maximum length of 2500 meters using 4 repeaters. It will only use for with the short distance. If suppose if you want to connect, create a larger network, so I think it is very tough to create using Ethernet. It will maximum support with the length of 2500 meters. Even for that also it required 4 repeaters because mostly that each cable in the Ethernet it support with the maximum 600 to 700 meters. Then you need 4 repeaters to cover even that entire 2500 meters using Ethernet. If you are going beyond that also, automatically the transmission loss will occur. So it won't support to connect to create the LAN with more than 2500 meters with the lane. So this is the frame format. It is theory only. You can kindly refer. So it is full and full theory. So you can maybe refer the slide. I will upload it. You can refer the slide. So this is Ethernet. You know that the token bus. This mostly we are not using. We are only using the token ring. But we will see about basics of the token bus. It is 802.4. So here, you know, it is nothing but the bus topology. We have seen bus topology. So in the bus topology, now that you know each it is having the token. So now the token will move from here to here. So all these things it is in physical medium. The dotted line it is a logical link because always token will move in a ring based. So token will move from here. Suppose if token is passed from one station to another stations. Suppose if token is containing it is holding the station 7, the station 7 only will able to transmit the information. Once after transmit informations, again it reaches the 7, it cross check token whether you know the respective the receiver has been received. If it is okay, then the token will be passed to the next stations. If 20 is containing any informations to transmit, it will call the token or it will pass the token to the next one, 14. If it is containing informations, then it will call, then it will add the information frame, then it will passes. Otherwise, it will pass to the next one without any information. Only thing in a token bus, it is very easy to include the stations. Now, if you see here, the station 19 is not included. So to include that, it is very, very easy. If you are creating logical ring along with the stations 19, I think it is very easy. But only the main drawback already we have seen the previous thing. If the physical medium of this bus, if it is broken, I think it is very tough to uh, 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 pass the informations. Yeah, the entire thing will be you know right side of the entire thing. It is not able to pass the information. That is the drawbacks of the bus topology. I think we have seen here the bus topology as well as token bus. Here you know like it is a combination of ring plus bus. It passes the token to the next one. If it contains, if it is having information to transmit, it will hold the token. It will add the informations. Otherwise, it will pass to the next one. Uh, it is very very simple. You can go through this. So mostly the token bus we are not using to establish the LAN because the main drawbacks, if the you know that physical medium, the bus if it has been broken, we cannot able to connect all the stations into the LAN using the server. So here the token ring plays the vital role. So next class we will see the about the problem using token ring, how to analyze the efficiency of the LAN by using a token ring. Suppose if you are creating LAN, what is efficiency? All these things I think we will see in the next class with the tutorial problems. Okay, so thank you. If you want to leave, you can leave.